Good afternoon, folks. Now the afternoon instead of morning. Okay, so we're doing AS Chemical Tests Lesson 2. So we're moving on to gases now at this point, folks. I'm going to try and be a little bit more speedy this time. So I'll start presenting straight away. So in this short video, we're going to be focusing on the gases that we need. Most of these, by the way, are a complete follow-over from GCSE. So Evans, if you attend again, this will be super useful for you because all of these apply, or almost all of them apply to GCSE as well. Let's share screen and go for entire screen. Oh no, my laptop's frozen. Oh, nuts. Oh, that's irritating. Oh, my laptop had frozen. Let's try again. Entire screen. There we go. Go figure. Okay, folks, I'll get rid of my camera like I did before because there's no point in having it. Okay, so folks, straight on to gas tests. I probably again ought to check just to make sure that it's actually there. Let's go to my channel just to see that it's actually working and the sound is working. Hey, we're there. Cool. I'll close that down now. Okay. Right, so hide. Okay, folks, so we're moving straight on to lesson 2 gases. So I think one of the things that it's worthwhile noting here is that when I started the series, I was talking about AS gas tests, and you notice I left a space, totally missed it. So an extension here from my previous lesson is that we need to make sure that we can test for our gases. And that's, so I've ticked off this one, organic is done, and we're moving on to gases for this stage. Okay, so at A-level chemistry, I need you to know the gases that we're testing for, the reagents that we're using for it, the observations, and I need you to be able to write equations for each of the reactions. Okay, so at A-level chemistry, there's 5 gases that you need to test for. Now, that is actually the same number that appears in GCSE. There's no actual difference. However, there are 4 other gases that you need to be able to know and recognize. So what I'm going to ask you to do is pause the video. I've suddenly realized I can technically use my phone here for this. Oh, I had a nice comment. Hi, sir. Glad to see you again. Your videos are always helpful. Hope you'll be posting some A2 content soon. What I'm going to do is pause. Can I show just the chat on my phone? That'd be super useful. So can't. Nope, really can't. Oh, well, never mind. More? No. Chat? Don't think so. Okay, so what I think you should do, guys, is pause the video and have a go. See if you can name the 5 gases that you need to know the test for, and then see if you can name the 4 other gases that regularly come up in topics in year 12 chemistry. Remember that these are not A2, nothing really changes when you get to A2. So I guess it's nice for me to add in AS at this point, but in reality, these actually apply to the the A2 course as well. So pause the video, have a go at doing your 5 gases and 4 others. Okay, so what are the gases that we need to know? So the first one I think it's worth starting with is we need to know hydrogen. Yeah, notice I'm giving the formula, but I'll also give the name as well. So hydrogen gas, very reasonable. We need to know oxygen gas. Yay, GCSE, absolutely as normal. Just make sure that when you're reading the question that you're RTF queuing it, read the full question. Because it's, if they say, give the formula for and state symbol of the gas, please give the formula, don't give the name. But actually, I tend to find that students tend to be caught out in the other direction. If it says, give the name of the gas, please write the name and not the formula. The next one is we need to know chlorine gas. Chlorine, gotta love chlorine. The next one is ammonia, NH3 gas. Ammonia. Notice ammonia, not ammonium. Ammonium is its ion, which we'll be seeing in the cation testing. But this is ammonia gas. Last one. Any ideas, folks? So we've got chlorine. Which one are we missing? We're missing one. Carbon dioxide. Lol. There it is. CO2 gas. carbon dioxide. Okay, so then the next question is, which gases do we need to know about, but not so much test for? So other ones include SO2. SO2 gas. There is actually sulfur dioxide. There is a test for sulfur dioxide. And I'll actually mention it just because even though it's one of those really awkward ones where it's not on your specification and they won't ask you for it, but they could technically throw you into the chemistry for it. I have seen it in the past. And what they were doing is they were doing a clever trick where they gave you the equation and then asked you to give what the observation would be. So that would be one to talk about as well. We also have NO2, nitrogen dioxide. These are all nasty gases, by the way. Nitrogen dioxide. Next one, H2S, hydrogen sulfide. Nasty, nasty gas. Hydrogen sulfide. Hydrogen sulfide. What's the other one that we need to come across? Other ones that we see, but bromine. Bromine gas. I'm also going to add a slash in here for iodine gas as well. So these are the other two that tend to appear in a variety of questions, usually, by the way, in the redox chemistry. Let's see if anybody's on my channel. Let's see if I can find it. YouTube, just to see if anybody's there to say hello. Let's have a look and view your channel. Let's see if I've got anyone there live saying hello. No, no one there yet. Bit sad. I won't check for a while now, folks. I'll just get through the video. Okay, right. I'm really hoping this is working. I've just suddenly seen that and just thought, is it working? Sorry, folks. Give me one more second. I'm just going to check one more time because I saw it go black and I just want to make sure that the sound is working. Yes, there we go. It's all good. Right, let's get rid of that and move on. Okay, so I'm going to go through these gases one at a time. I'll do the test for it. I'll do the observation, and then I'll write the equation for the reaction. Okay, so first one, I really don't need to do this one, folks. So gas number one, hydrogen. I'll give that a bit of space. Nice to have better notes. Okay, next for the first gas, it's hydrogen, H2. And you guys already know this. This is a GCSE classic for hydrogen gas, H2. Remember, any elements ending in gene or ene or gen, I blended them together, are going to be diatomic. So that's something that's nice to mention. Gen or ene, they're diatomic, and that literally tells us the number 2. So, okay, so the actual test for this gas, so the test is a lit splint. Lit splint mixed with sample, added to sample. Yeah, it's actually just lit splint. So observation from this, observation, everyone knows it. Pause the video, see if you remember your good old squeaky with all of the vowels, squeaky pop sound. I like it. And the equation for the reaction, I'm going to swing the equation over to the other side, give me a bit more space, is just the combustion. So this is H2 plus O2, giving us H2O. Balance the equation. You can balance it with a half if you like. A level, I always try to encourage people to balance with a half. Let's include we could double it if we wanted, and just include our state symbols. And it's nice just to recall, by the way, nota bene, the water is coming off as steam. Yeah, this is not coming off as liquid water. Yeah, this is coming off as steam or stroke water vapor. 2 different names. By the way, commonly asked, give another name. GCSE, good grief. Give another name for steam. So very common question. Really nice test to do. All the chemistry teachers, we love this one. It's our favorite gas, probably. Okay, so gas number 2. Let's move straight on to oxygen. Okay, gas number 2. Gas 2. Okay, so this one is oxygen. Gotta love oxygen. Oxygen's an amazing gas. It's so much fun to play with. Slash. Nice to recognize the gen here. Just a reminder, you know, if it's a gen, it's got to be in a pair. Give our state symbol. Always nice. Okay, so test for this gas, nice and easy, is a glowing splint. Don't know why I capitalized that word, but I did. Yeah, a glowing splint. And the observation is going to be it relights. Relights the glowing splint. Relights the glowing splint. So it'll just cause it to catch fire again. Relights glowing splint. Okay, and equation for the reaction. Now, there isn't so much an equation for this one, so much as an explanation. It's kind of a nice segue into realizing the different kind of styles of question you get at GCSE and A-level, and these two are just subtly different. So it's nice to see this explain why it relights it. So increased concentration. Increased concentration. Now, this is important. This is actually, by the way, every time this question makes an appearance, students really stumble on it because in the air, we've got 21% of oxygen anyway. Yeah, this is the nota bene really for this. In air, we know that we have 21% O2. So it means that when you're testing for a pure gas, that the explanation requires this to relate it to an increase in concentration. So increased concentration of oxygen gas, next bullet point, leads to more complete combustion. More complete combustion. And we know that more complete combustion releases a larger amount of energy. So an increase, a larger, so more let's go, let's go even better. So more exothermic will release more energy. More exothermic, causing flame to reappear. Flame to reappear. In reality, there's no actual mark for that last one, but it's nice to add it. Cause flame to reappear, because essentially what's happening is we know that glowing basically means it's a horrible word called smoldering, which is that it's still combusting. You know, the wood particles, which are mostly carbon based, they're still going to be burning to a certain extent. It's going to be incomplete combustion, forming things like carbon and carbon monoxide, which produces less energy. But then once it gets complete, more exothermic, which will lead to you producing more vapor. When something is burning, by the way, solids don't burn, gases burn. In order to get a flame, see, people forget that, an actual flame on a candle is actually a mixture of gases. It's carbon dioxide and water mostly, but the heat is causing the fuel to vaporize, and then that vaporizing mixes with oxygen, leading to actually the generation of a flame. So a lovely question there, and it's so nice to see us switch from doing a kind of a simple equation as to what's happening through to we can't really so much give an equation. You could argue that you could apply this in terms of wood as a compound, but it's very complicated. So they like to switch to this idea of an explain question, where this, as I said, referencing the increase in concentration and more complete, more exothermic. 3-mark question in the exam. Tough question that when it appears. Kind of rare though. Okay. So we've done oxygen. We're smashing through this. Won't be a very long video, this one, folks, which is great, right? Everyone likes a short video. Right, gas number 3, chlorine, underlined. So we've got gas number 3. Gas number 3, good old chlorine. So it's nice at this point, we finally get to a point where we're seeing a gas with a color. Yeah, so Cl2, recognizing, by the way, any elements ending in ene will also be in a pair. Chlorine, bromine, iodine, fluorine, etc. And this one actually picks up a color. So we see an observation now for this gas. This is a pale green gas. I'd actually just call it a green gas. Fluorine is a pale green gas. So you'd say that fluorine is a pale green, chlorine is a green gas. And then they get darker as you move down group 7. But this is not a group 7 lesson. It's just a gas test lesson. So what is the test for chlorine gas? Okay, so how do we test for it? It's a very straightforward test, actually, but it has some beautiful observations, and it actually has some lovely equations, too. So the test for this is damp, and that's really important, underlined, damp blue litmus paper. This is the test for chlorine gas. Damp blue litmus paper. Okay, so what are observations on this? Now, the observations at GCSE are very simple. You're going to say that it's going to go from blue, and you're going to say that it just bleaches. That's GCSE. But at A-level, there are 2 observations. It will go from blue to red, then isn't, I love that. I love the change in the language. It says blue to red, then. So it's then saying after it. Yeah, I just love the change in the language. Blue to red, then bleaches. If anybody is watching this who's doing GCSE, like Evans, for example, Evans, you just actually say blue to bleaches. Yeah, and bleaches, by the way, you can also then just say then bleaches, or you can say then turns white. That is an alternative. You can say turns white, then turns white, if you prefer. Either one of those is acceptable. Turns white. Bleaches, to bleach something means to turn it white. You know, if you bleach your shirt with household bleach, you end up getting white on it. If you bleach your swimsuit in the swimming pool, it's turning white. And there is a very clear equation for this. Now, this equation is not needed for GCSE, but it is needed for A-level. So chlorine gas. Now, by the way, chlorine has its very own lesson, A-level chemistry, because there's a lot of chemistry we do for chlorine. So please don't think that this is kind of the only equation it does. But chlorine gas with cold water, with no sunlight. Yes, that's right, folks. Chlorine has its own lesson and lots of detail. But if you do this with cold water, what will happen is you will get a very simple reaction. You'll form HCl, and that causes it to the blue paper to turn red. I want to pick a nice pale red here. Everybody else would be nice. I like a pale because I can highlight it in pale red. This is what causes it to be red because it's acid, right? And it's going to be aqueous. Yeah, water is going to be liquid and chlorine is going to be a gas. State symbols appearing. It's nice to see all of our state symbols. We are also then going to get HClO. Yeah, this is really important. This is called hydrogen chlorate. Hydrogen chlorate. And you need to now get a Roman numeral of 1. This is because the chlorine has an oxidation state of, pause the video now, have a go at your oxidation states. This, Evans, bit of a challenge for you here. Have a go at the chlorine oxidation state. Okay, so how do we work out the oxidation state of the chlorine? In HClO, I'm asking you about the chlorine. What that means is that everybody else in the compound must be standard. Yeah. So what that means is we know that hydrogen always becomes +1 and that oxygen always is 2-. There's no overall charge in the compound, which means that chlorine must be bringing a +1 oxidation state. Hence the Roman numeral. Kind of nice. I like that. So chlorine's in a +1 oxidation state. So many lovely bits of redox appearing in these questions. And this compound is mild bleach. This is mild bleach, everybody. Yeah, and this is why when you're in the swimming pool, if you forget to wash your swimming costume after you've been in the pool, yeah, this is the compound which actually causes your swimming suit to lose its color. It is a mild bleach. Mild bleaching agent. Mild bleaching agent. Okay, and if you're interested, and by the way, it'll also be aqueous. If you're interested, though, you know, when you go swimming, those swimmers in the class or who are watching this, when you open your eyes underwater, your eyes sting. Well, surprise, surprise, you've got hydrochloric acid in here. This is going to make your eyes sting, and this is, of course, why the paper turns red. Yeah, we know that damp blue litmus paper turns red in the presence of acid. So nice to kind of see this, and it's such a beautiful equation. As I said, I'm not doing a chlorine lesson. Chlorine does a whole load of other side reactions. When you have things like in cold water in UV light, you don't produce hydrogen chlorate 1. What you do is you produce oxygen gas and HCl in reality. But as I said, it's not a chlorine lesson. This is the one for the chemical test, hence the bleaching. Okay, chlorine done. Are there any other tests for chlorine gas? No. I've suddenly realized, guys, there's an extra gas we need to add here. Gas number 6 is HCl. HCl gas also needs to be on our list. Hydrochloric acid. It's so nice. As a teacher, I don't ever pretend to be infallible. I try to obviously catch as much stuff as I can. And I'm then suddenly realizing, you know, oh, based on this one here, suddenly realize that they can ask you for the test for hydrogen chloride gas as well. Notice, by the way, I'm not calling it hydrochloric acid. HCl in water is hydrochloric acid. As a gas, it's hydrogen chloride. Okay, let's move on to the next one. Oxygen gas done. Oxygen gas, chlorine done. We're moving, smashing it. Right, ammonia. Let's move on to the next one. Gas number 4. Love it. Doing well. So, gas number 4. So, gas number 4 is ammonia. Sorry, singing. It's called ammonia. I'm going to state symbol. NH3 gas. No charge. Those people doing mechanisms don't put charges on ammonia. Okay, so let's have a look. So ammonia test for this gas. Nasty gas, by the way. Really toxic. By the way, actually, there has been an exam question which relates to this gas test, actually, which then did the toxicity of ammonia. It was a really nice question. I'll talk you through in a second. The test for this gas is very straightforward. There are, in fact, 2 tests. So, test number 1, test uno. Test number 1 is we are going to use damp. Underline damp must be water. You'll see why in a second. Oh, by the way, why does it need to be damp? Suddenly realizing, guys, skipping parts of my lesson. Why does it need to be damp? Because you need the water in the equation. No damp, no change. This is another one. I need water here, folks. I've got damp red litmus paper. Notice I've switched color. Yeah, this is not damp blue litmus paper like chlorine. This is now damp red, which means it's detecting an alkali. Let's do the observation. Observation is going to be, it turns blue. Red to blue. Always give the before and after. Red to blue. So it's telling us that ammonia is an alkali. We pick up a nota bene here, folks. Year 13 spoiler. Nota bene. NH3. Ammonia is pH 11. Weak base. Yeah, it's a weak base. Partially dissociated. We'll see that in our question in a second, by the way, which is kind of nice. So observation red to blue. Now we need to write our equation. So we've got ammonia. NH3 is going to react with water. H2O. Let's put gas. Let's put liquid. And now look, it now becomes a reversible arrow. Now this reversible arrow is all about it being weak. This is a weak base, so it's reversible. Yeah, this means partially dissociated. Partially dissociated. Cool. Next. And what's it going to form? It forms ammonium hydroxide, aqueous. And it's nice here to pick up. So which ion is actually changing the litmus color? This is a nice nota bene here, which is the OH minus ion. The OH minus ion is the ion that causes, this is the alkali ion. Yeah, this is the alkali ion. The ion that makes anything an alkali. Yeah, is OH minus, not the NH4, NH4 plus, be careful, sorry. NH4. So the OH minus ion is what makes an alkali an alkali. Nice nota bene appearing there. Nota bene, we know 2 ions. H plus is what makes an acid an acid. Yeah, this is an H plus is acid. Yeah, it's just nice to kind of pick up these things. And OH minus is alkali. Gotta love it. Put that in a box. That comes up a lot at GCSE and A-level. Okay, so it's nice to see this. So we realize why it needs to be damp. We can make that connection because the water appears in the equation. Always cool. Yeah, and it turns blue because of the formation of the OH minus ion. There is a second test, and that second test is the same test for hydrochloric acid. Isn't this lovely? I just suddenly realized it was going to bounce, hence why I then added it. So test number 2, this is an interesting one because we can do this as test 2. Test 2 for ammonia is concentrated HCl. So this is concentrated, you've got to say concentrated, by the way, can't do it with aqueous, concentrated hydrochloric acid. Shouldn't write HCl, let's write hydrochloric acid. Hydrochloric, concentrated hydrochloric acid. And so by the way, this is the test. I should test, oh, come on, Mr. Duncan. Test 2 for ammonia gas. Test is conc HCl. And the observation is going to be white smoke. We saw this in our organics video when we were testing for the amines. Love the overlap. Yeah, equation. Now, what I need to actually do here, folks, is this is test 2 for ammonia, but also we pick up a nota bene. Also, it's a little baby nota bene here. Also test for HCl. Yeah, for HCl gas, which is ammonia. You're going to add concentrate. I shouldn't do it like this, should I? It needs a separate box. The equation is ammonia gas will react with HCl gas, if you like. You can do this. That's why it needs to be conc, because it's going to give off smoke. Yeah, and it will form ammonium chloride salt, which is an ionic solid, hence the white smoke. Smokes are solids, fumes are gases. Yeah. So actually, you don't actually need to mix if you've got two solutions, you just put them nearby. And by the way, they give you these kind of bizarre images. So the example kind of question that tends to come in here is you could imagine having a beaker of your ammonia, ammonia solution, aqueous. And if you put it nearby, a beaker of concentrated HCl, conc, what will happen is you will form smoke here where the two gases are diffusing. It's going to evaporate, diffuse, and then where they meet, I'm going to get white smoke. They do come up. So I could make a separate note for this, guys. So 2 tests for ammonia comes up, links to amines as well. So I can also really tick off the HCl one. Let's go on to the next test. Gas number 5, CO2. This is a nice short video, folks. Gas number 5, carbon dioxide. Okay, carbon dioxide. Okay, CO2, gas. State symbols. Okay, now carbon dioxide gas, you guys have known this forever. The test is, now, by the way, guys, notice my capitalization and changing words because the amount of students who forget this. Bubble through. You need this, folks. You can't just say lime water. Yeah, because if you just say lime water, if you just have lime water out on the table, it's not going to detect your gas. You've got to bubble the gas through it. So bubble the gas through lime water. Observation. This is A-level white precipitate. By the way, they will still, which really drives me nuts, they will still accept turns cloudy. Just cloudy or milky. Ugh. It's because they're preview. I hate that. It's so annoying. White precipitate is better. Let's look at the equation. Okay. So what the heck is lime water? So lime water is calcium hydroxide aqueous. That's what lime water is. This is where I can use my beautiful tablet in order to go lime water. There we go. To make the link in our highlighter. Gotta love it. And lime water reacts with CO2 gas, state symbol, to form limestone, which is a white solid, calcium carbonate solid, and water, liquid water on the back. So there's your white precipitate. Again, we can tie this in with our highlighter. Our white precipitate is the formation of limestone, which is insoluble, group 2 carbonates. Yeah, if anybody's sitting there doing AS Unit 2, group 2 carbonate solubility, all group 2 carbonates are insoluble, folks. It's just an easier way to do it. Magnesium carbonate's not soluble. Calcium carbonate's not soluble. All the transition metal carbonates are insoluble as well, by the way. Anyway, so good solubility rules there. Cool. Cool. So calcium carbonate, nice. Now, this one requires a bit more of a conversation because this one, they have, so by the way, at GCSE, you're done. But at A-level, they can do something really sneaky, which is if you took a boiling tube of limestone, of lime water, if you took a boiling tube of lime water, calcium hydroxide, Ca brackets OH2, aqueous. I'm going to get rid of that first bracket. There we go. Lime water. And you bubbled CO2 into it, Just going to do it like that. If you bubbled CO2 into it, the first immediate observation is that it turns cloudy. The whole thing will become really murky and cloudy with a white precipitate. It's not gray, by the way. It's just, there's no point in me doing a gray. Okay, I'll probably do a gray, actually. Let's try a gray. Nope, that didn't work. Let's try again. Lol. Let's try that one. Okay, there we go. I form a white precipitate. Yeah, white PPT. But here's the interesting thing. If you continue to bubble more CO2 through, it'll vanish again. So this is excess CO2. It'll actually redissolve. Now, this has been on papers. It's the A-star question. Then it's not often, it's really rare, but it will actually disappear again and become a colorless solution. So this is me going the extra mile, folks, colorless solution. So what's happening? In the first equation, it's nice just to put these all next to each other. In the first equation, the calcium hydroxide is reacting with the CO2 immediately and forming calcium carbonate and water. And the reaction essentially halts at that point, and there's my white precipitate. However, the carbon dioxide, now that all the lime water, all the slake lime or calcium hydroxide, now that that's gone, the CO2 will now start to react with water to form, by the way, in a reversible direction, because it's weak, it's going to start forming carbonic acid, which is aqueous. So this is called carbonic acid. Now that carbonic acid is, of course, an acid, and it will start reacting with the basic calcium carbonate. So if you take calcium carbonate and you react it with carbonic acid, what you end up creating is calcium hydrogen carbonate, which is this guy, which is soluble. It dissolves. It's such a nightmare. Can we just check that it all adds up in terms of atoms? I've got one calcium, two hydrogens, two carbons, ooh, a lot. 3 there, 6 oxygens, all adds up. And that now redissolves. That was when that came up on the paper, I was absolutely blown away by it. It was a suggest question, A-star one, really hard, really clever. I loved it. Proper stretch and challenge, proper grade A-star. Okay, carbon dioxide. Is there any other thing? Now, there isn't any other tests for CO2. We wouldn't do it. We wouldn't call it a test, but there are. I'm not doing a carbon dioxide reactions lesson, am I? I'll leave it to that. I've suddenly realized there's another gas I need to test for. Hey, let's put that one in as HCl up there like that. I like putting it as red to make the others. There's another one, water vapor, H2O. It's so easy to miss these things. H2O gas. Okay, so ammonia, carbon dioxide, done. I was going to mention some of the other chemistry regarding carbon dioxide, but yeah, that's for another video. Okay, so gas test number 6. HCl, already covered it. So with the test for HCl gas is to use concentrated ammonia, white smoke. I'm going to make the note anyway. Gas number 6. Gas 6. I may as well. If I'm going to do it. I'm suddenly realized that my notes are getting really big and I don't really want them to. I'll zoom in a bit more. So gas number 6 is HCl, hydrogen chloride gas. Notice it's not hydrochloric acid. This is hydrogen chloride. It's nice to actually do it properly. As a gas, hydrogen chloride, as an acid, hydrochloric acid. The test for this is concentrated ammonia. Test is concentrated ammonia. And you just put it nearby, and it will produce white smoke. We've already seen it. Conc ammonia, observation, white smoke. Observation, white smoke. Equation, we've already seen of I ought to put HCl first because that's the gas I'm testing for. It's nice to flip it over, right? HCl gas plus ammonia gas goes to white ammonium chloride solid as an ionic solid. Cool. By the way, all of these have been in. I just had intermolecular forces come into my head. This one's dipole attractions. Dipole attractions. This one is this is hydrogen bonding, H bonding, and this one, of course, is ionic. Yeah, the last time this made an appearance, they actually asked you then to talk about the melting points of each of them and predict which one would be higher, which one, and put them in order and explain why. It was really clever. So just nice to link that to intermolecular forces and bonding, ionic, for example. This one, of course, also has dative covalent in it as well. It's got everything. Anyway, moving on. It's for different lessons. Bonding. So we're smashing through this, folks. Last one, water vapor. Let's have a look at water vapor. How do you test for water? Now, you guys know this one, gas number 7. Gas number 7 is H2O, is water gas. Steam, yeah, steam, water vapor. They love all these questions where they ask you for the alternative names and they can move between them, synonyms and all that. Okay, so how do you test for water vapor? You test it the same way that you do for it as a liquid. So you're going to test for this with anhydrous. Two tests. Test number 1. Test number 1, Evans, this is super useful for you because both of these come up on GCSE. Test number 1 is anhydrous copper sulfate. Anhydrous copper sulfate, and it'll go from white to blue. What? White to blue. Oh! Having a moment. Anhydrous copper sulfate. My brain's working faster than my hand can, and it turns from white to blue. White to blue. Equation do we need to do an equation for that? Yeah, you can do. It's not GCSE. You don't need the equation for this one at GCSE. This is actually year 13, if I'm honest, which is Cu2 plus as a solid. Yeah, and you're adding water to become Cu2 plus aqueous, and that's blue. Yeah, if you want, I can give you the year 13 spoiler, folks, if you want me to, but I won't. No, there's no point. It's madness. Let's avoid it. It's in year 13 that you actually pick up that real equation. Last one. So test number 2. Again, still at GCSE as well. Changing my color for once. You'll see why. Hey, gone pink. The reason being is test number 2, anhydrous cobalt chloride. Anhydrous cobalt chloride. And this one is it changes. I always like highlighters, white to blue. It's nice to, there you go, white to blue. And this one, you learn these in a sequence because this is blue to pink. This is blue to pink. I love it. Again, no equation needed. Blue to pink, you learn it in year 13 is where you come across that equation, but you don't need it, which is great. Okay, is there any other tests that I would do for water vapor? No, not really. Cool, those are done. Okay, we've done all of our gas tests. It's nice then to mention the gases to know. So sulfur dioxide is a choking gas, very toxic. I'm gonna add this in. So gases to know. It seems reasonable. If I'm gonna do a lesson like this that I get to keep online, it's nice to be thorough about it. So gases to know. Gases to know. Okay, so let's just start off with gas number 1, and that's SO2. SO2 is a sulfur dioxide. Sulfur dioxide. It is a toxic choking gas. Toxic choking gas. Now, I mentioned the choking because it came up in an equation once. So SO2 being toxic is just because it's toxic. But the choking thing is a bit more specific. So SO2, when this, as I said, I'm adding these to know because of the questions that they ask about them. There is a test, by the way, for SO2. Okay, I'm going to add this just for fun. It was on a question, by the way, so I ought to do it. So the test for this gas is potassium permanganate aqueous. This is, and we've seen this before, saw it in our organic, potassium permanganate aqueous. Don't forget bubble through. Don't forget it. Bubble through potassium permanganate aqueous. Now, potassium permanganate is a beautiful purple. We know this one. Yeah. And oh, by the way, it needs to be acidified as well. It actually doesn't need to be acidified because it acidifies itself, but they won't mind if you say it. So I quite like to do it. But as I said, you don't really need it, but it's nice to do it. So acidified potassium permanganate. I'll write the name as well. Potassium, because of course you're listening to my voice, but you might miss certain things. Permanganate, and it's purple. And the observation for this is it'll go from purple to colorless. So it goes from purple to colorless. Anyone who's just watched my other video, you'll probably know what the colorless species is. And that colorless species, which is actually pale pink, is Mn2+. So what's happening is it's an oxidizing agent. The SO2 is being turned into SO3. That's actually what's happening. It's being oxidized into a higher oxidation state. And the permanganate is being reduced from Mn+7 to Mn+2. Kind of nice. Purple to, sorry, I'll put colorless there. Shouldn't do that. Colorless. Okay. And one of the things is you don't need the equation for it. We can construct it for A level, by the way, but I'm not overly too worried about that. Oh, shall I? Yeah, okay. Just for fun, they have done it. Equations. MnO4 minus purple is getting, I'm going to do this properly. Evans, this will be a bit hardcore, really. And this is going to go to Mn2+. We can balance the half equation using Moe. We saw Moe in a previous video. Metal, water, acid, electrons. The metal is manganese, already balanced. Gotta love it. Tick. Water for oxygen, add H2O. Gonna need 4 of those for each of the oxygens. Tick. Need acid for H's, got 8 of them over there. 8 H pluses. Now balance for charge over here, plus 8 over here, plus 2. Add 5 electrons to that side because it's more positive, and I'm done. Cool. So there's our half equation for the permanganate. What's happening? And we're going from purple to colorless. It's nice to just keep consistency. What's happening to the SO2? The SO2 is going from SO2 to SO3. Let's balance the half equation. So we've got metal. So metal is sulfur, 1 and 1, done. Water for oxygen, add the H2O. Acid, H pluses for hydrogen, 2 H pluses, plus 2 E minus on that side for charge. We can blend them again, multiply this one by 2, multiply this one by 5, put them together for the overall equation. This is not a redox lesson, not getting into that. But that is essentially what's happening, is it's being oxidized to something else. Because sulfur can exist as SO3 as well, we can do a simple test. You can also use potassium dichromate, by the way, which will go from orange to green, but they've never asked it, but they could. Anyway, so we can test for this gas. The last time I made an appearance was to do with its choking property. So SO2 is a choking gas. And the question, why choking? Choking is when... Sorry, folks, this is a ridiculous thing for me to do. But choking means choking. The question is why? This is because SO2 reacts with the water in your lungs to form, now you've got to be really careful with this, sulfurous acid, not sulfuric, but sulfurous. And that's it's about pH 4, and it's acidic, so it burns your lungs, and it's a nasty gas. But it has been up every now and again. Gases to know. It's also colorless, by the way, as a gas. Okay, SO2 done. Let's tick it off. I'm loving these lessons where I just get to tick off all these gases. Right, NO2. NO2, there is a test for NO2. You don't need to know it, which is great. And they've never actually asked it, which is kind of nice. But NO2, so gas to know, which is nitrogen dioxide. NO2, nitrogen dioxide. Nitrogen dioxide. Okay, nitrogen dioxide, again, is a toxic choking gas. Fume cupboard all the way. Yeah, toxic choking gas. And here's the important bit. It's brown. A true dark brown gas. Nasty stuff, NO2. Yeah, it's a brown gas. So observation of this gas, observation is it's brown gas. Okay, so no, now the test isn't really a test. The test is more like the fact that you can actually, if you took a sample of this gas and had it in a tube, and this isn't a chemical test, it's a wrong description. If you had a sealed tube containing this brown gas and you wanted to prove that it was NO2, there's a really simple thing you do, which is you put it into, you got to be careful here. I need to get this right the right way around. You warm it up. You put it into a beaker of warm water. So you take your little ampule and you put it into warm water. And what you will see is this. It'll get paler, which is really interesting. So here's what's happening. So the observation, that the test is place sealed tube in warm water. Place sealed tube of gas of NO2 in warm water. There's the test. Warm water. Observation. Obs is going to be becomes paler. Becomes paler. Equation becomes pale. Okay, paler. Okay, equation. NO2 is actually in equilibrium with itself to form N2O4. And this is a brown, NO2 is a brown gas, whereas N2O4 is colorless. And the forward direction, mexobendo, making bonds is exothermic. Oh, shoot, I've got it the wrong way around. Oh, Mr. Duncan, I hate it. Oh, I've got it wrong. Forward direction is exothermic because it's making bonds. Damn it. Making bonds. And making bonds is exo. The backward reaction is endo because it's mexobendo. Breaking bonds. To break bonds, you need to provide energy. I've suddenly got this the wrong way around, folks. I'm so sorry, everybody. Oh, so easily done. Put it into cold water and it'll become paler. If you put it into hot, it'll get darker. This is cold water, ice water, and ice. Darn it. I'm so sorry, everybody. I don't pretend to be flawless, everybody. I've got to build this. Yeah, I don't have all this stuff just learned in my head. It's just, it's nice to see if I can find an actual image for this. So NO2 in cold water. Let's see if we can just check this. NO2, cold water. There you go. In an ice bath, it'll become paler. Nice. In warm water, it'll become darker. Ice bath, paler. Darn it. I'm so sorry, everybody. If you did warm, it needs to become darker. I apologize. I got there eventually because I had to build it knowing mexobendo. But anyway, I apologize. So it's not a true chemical test, but it comes up if they ask you about its choking nature. This is a bit more complicated than the SO2. So NO2 is choking, which means it's another acid gas, hence acid rain. NO2 reacts with water in an equilibrium to form nitrous acid and a mixture of nitric. This is horrible. Balance the equation. Does this add up? Two nitrogen. Don't do it this way, Mr. Duncan. Two nitrogens. We're good. Next, oxygens. Gross. 4 oxygens here because of the 2. 1 oxygen, 5 in total. 1, 2, 3, 4, 5. All adds up. Like it. Next, hydrogen. Switch color. Hydrogen 2. Hydrogen 2. It all adds up. So actually, this is a very interesting reaction. They do love this reaction. If you run oxidation states for this, oxidation state, pause the video, have a go at doing it. For nitrogen in this is going to be a +4. Nitrogen over here, we've got minus O2 minus times 2, so -4. We've got H +1, so +1, which means the N must be in a +3 oxidation state. Nitrogen for this one, pause the video, have a go. So this one's going to be O2 minus times by 3, giving us -6. H plus for that, +1, which means this must be in a +5. Ah, interesting. This is a disproportionation. We have nitrogen going, but this is now a reduction. This is the reduction reaction when the nitrogen gains 1 electron. Yeah, so this is +1 E minus to go from +4 to +3. It's gone down in charge, but it's also been oxidized as well. So it's actually lost 1 E minus. So this is actually called a disproportionation. It's a type of redox, Evans, if you're listening. Really cool. You don't need it till A level. It's kind of nice. And that has been on papers before, by the way, for AS. Okay, and NO2, done. Let's tick NO2 off. Okay, next one, H2S. We're nearly done, folks. Last 2 gases, we're nearly finished. We're doing really well. Underline. Very little to know about this, folks. H2S is a toxic gas, and this is the important bit, with a bad egg smell. If you ever smell bad eggs, this is a common misconception. People think it's sulfur. It's not. It's H2S. Hydrogen sulfide has the bad egg smell. Sulfide's a solid. It doesn't smell of anything. Hydrogen sulfide. Nice. Nasty toxic gas with a bad egg smell. And that's it. That's the test. No test for H2S except for the fact that you're gonna smell it. Really nasty. Really, really toxic, by the way. In terms of, by the way, it's almost as toxic as cyanide. This stuff is lethal. Okay, we've got that. Nice, easy test for H2S. Last one, bromine and iodine, gases to know. Again, we could argue that there are tests for these. So we can do bromine. Br2 is a brown gas. Brown gas. A brown gas. A bit like NO2, by the way, we could prove that it's bromine. So there is a test for this. The test for bromine gas is to bubble through. I love the fact that I lost a B. It's my dyslexia coming out. Bubble through. We're going to go for potassium iodide aqueous. So potassium iodide solution. And what will happen is, observation is, it will turn red-brown. So it will go from colorless, because Ki is colorless, potassium iodine solution is colorless, to orange, red. Red-brown. It's better to say red-brown. Red-brown. And the reason for this is because of the production brown. This is because Br2 gas is going to react with Ki aqueous, which is colorless, to form KBr aqueous and I2. It's a displacement, standard displacement, also a redox, but displacement. Yeah, real displacement. It's one swapping for the other because it's more reactive. Yeah, so we've got bromine being reduced and you've got iodide being oxidized. And there's our red-brown. Nice to see that we've gone from colorless Ki and we are forming our red-brown iodine aqueous. Don't forget your state symbols. Cool. Okay, that's how you can prove that it's not NO2. Nice. If you do that with NO2, it doesn't do it. Okay, last gas, iodine. We're there, and then we can jog on. No. Cool. We could, by the way, extra test for chlorine, bubble through Ki, or bromine water. Anyway, sorry. Last one, iodine. Oh, iodine gas now this is a very important one because it's beautiful and purple. It is a purple vapor, purple gas. They like to use the word vapor. Don't know why, they just do in this case, purple vapor, purple gas. How do you test for it? With great difficulty. The answer is you use, it has been on before. A student had a gas, a jar full with purple gas. So the jar was full of the purple vapor and they wanted to do a test. And what they did, something similar to the bromine, they lowered its temperature. They put it in an ice bath. You put it in an ice bath again. The purple color will fade, and what you will get are gray crystals. The purple vapor will vanish. The purple vapor will disappear, and you will form gray crystals. One highlighter. Gray crystals on the beaker, all over it equally. You form gray crystals. This is iodine as a solid. Gray solid, brown in aqueous. You form a gray solid of iodine solid. Gray solid, I2 solid, not gas, solid. Can't displace it the way that you do with bromine because iodine gas wouldn't displace anybody because it's less reactive than all of them. You have the bromine, you have to use Ki because iodine's the only one that's less reactive. Right, guys? Gases are done. Tick, tick, tick. Amazing. Right, gas tests are finished, folks. Let's go back to my StreamYard. Bring my camera back. Stop presenting. Bring my camera back. Way. 1,000 subs with no vids. Watching from India. Nice. Hi, Russell. Nice to see you, buddy. Thanks for coming. Guys, gases all boxed off. I hope you find it useful. Have a nice rest of your day, folks.